So today we're going to be working on our inverse functions some more, and you'll need the Introduction to Inverses worksheet. This is the classwork. You have a separate sheet for homework called Verifying Inverse Functions. Today we're looking at these two functions, f of x equals 2x plus 6 and g of x equals 1/2 x minus 3. And we're going to complete the table for each function by just substituting x into first f of x and getting an output, and then also substituting these values for x into g of x and getting an output. So we'll do that real quickly here. -4 substituted into f of x produces an output of -2. Over on the side, if you need to, 2 times -4 plus 6 is -8, plus 6 is -2. You can do that on your calculator if you need to, or on paper. But filling in the rest of the table, when we sub -3 in for x, the output is 0. When we sub -2 in for x, the output is 2. And -1 gives an output of 4. Subbing 0 in gives 6, and subbing 1 in gives 8. If you need to check these values by subbing them in for x, go ahead and do that. Coincidentally, these output values for f of x are now our input values into g of x. So you see these values are the same over here. When we sub them in for g of x, if I take -2 and put it in for g of x, I'd be doing 1/2 times -2 minus 3, which is -1 minus 3, which is -4. And if I put 0 in to the equation, I'll end up with -3. Putting 2 into the equation, I end up with -2, and -1, and 0, and then 1. And notice that g of x has now undone what f of x did to our x values. We ended up right back at the same place that we started with for our x values. So since g undoes the effects of f of x, these are inverse functions. An xy pair in f of x is reversed. -4, -2 in f of x is reversed to -2, -4 in the other function, g of x. Okay. So those are inverse functions. And if we graph them on the chart, starting with f of x equals 2x plus 6, that has a y-intercept of 6, and for every 1 to the right we move up 2 using the slope, or down 1, left 1 and down 2, and left 1 and down 2. And all these points are the points that we had here in the table. And if we graph g of x equals 1/2 x minus 3, if we use these points, -2, -4, and 0, -3, 2, -2, and so on. We get two linear functions. Where the x and y values have been switched. graphing the line h of x is equal to x, that's just the parent function, or parent linear function, just going right through every point containing an equal x and y value. And you can see that this line has been reflected. These two lines are reflections of each other over that line y equals x. So for writing what we notice, that f of x and g of x are reflections of each other over the line y equals x. Now we're asked to compose these two functions, f of g of x and g of f of x. So our first one, we're going to take g of x and substitute it in for the variable into f. So that means we're going to do 2 times the quantity 1/2 x minus 3 plus 6. Because f of x is our function 2x plus 6, and we're using g of x as input. So 2 times 1/2 x minus 3 plus 6 composes the two functions. If we distribute the 2 through the parentheses, 2 times 1/2 is just 1x. 2 times negative 3 is negative 6. And then plus 6. And this just simplifies to 1x, or x. When we do the composition the other way, g of f of x, now we're taking the function f and substituting it into g. So we'll have 1/2, that's how g starts out, times 2x plus 6 minus 3. And distributing the 1/2 through, we have 1x plus 3 minus 3. And that just simplifies to 1x. So in each case, when we did f of g of x and g of f of x, we ended up with 1x. And that's a way to show that two functions are inverses. Going on to the next page, the idea is the same, so I'll let you complete those. You can check your answers on the answer key on Google Classroom. And I'll remind you that just to use your transformations, f of x is a cubic function, g of x is the cube root function. F, the cubic function, shifted to the left 4 units. And g, the cube root function, shifted down 4 units. When we do those two graphs, because I think you'll be able to do the tables by yourself, looking at f, we would shift to the left 4 units, 2, 3, 4. There's our center value, moving right 1 and up 1, and left 1 and down 1. And right 2 and up 8. 1, 2, 3, 4. And from the center, left 2 and down 8 will put us down here. So that's f of x. And g of x, the cube root function, shifted down 4. And moving right 1 and down, up 1, and left 1 and down 1. And again, if we graph the line y equals x, you should be able to see that these two functions are reflections over the line y equals x. So these two functions, x plus 4 cubed and the cube root of x minus 4, are again going to be inverses of each other. So if we look at the composition, f of g of x, we're going to take g, the cube root of x minus 4, and put it into f. So we would be doing the cube root of x minus 4. That's substituting here. Plus 4 cubed. This is g of x, and we're putting it into f of x. So, negative 4 plus 4, those two things add up to 0. So now we just have the cube root of x being cubed. Using properties of exponents, that's the same as x to the 1/3 being cubed. And multiplying 1/3 by 3, doing powers of exponents, we get x to the first power, which is just x, and so f has undone the effect of g. And we'll do the same thing, g of f of x. That means we are putting x plus 4 cubed into g, and that says we're going to do the cube root of x plus 4 cubed minus 4. Taking the cube root of something cubed essentially cancels the exponents. You can also say that this is x plus 4 cubed to the 1/3 power, and you would multiply those exponents and get 1. So that becomes x plus 4 minus 4, which equals x. So again, the functions have undone each other, and you end up with x in each case, so those are inverses. Finishing the worksheet here, how can you use graphing to test if two equations are inverses? When we graph them, in each case, when we graphed them and reflected over the line y equals x, or looked at the line y equals x, it was shown that those two graphs were reflections of each other. So you can use graphing to test if two equations are inverses if they are reflections over the line y equals x. And how can you use composition to verify two equations are inverses? You can use composition to see if, in each case, if f of g of x ends up being x and g of f of x ends up being x. You should have enough information now to go ahead and work on the homework. This last page of this packet we can talk about tomorrow when I return in class. Good luck with your homework. You can check your answer keys online if you need extra help, and I'll see you tomorrow. Bye.